I'm Anil Kumar sharing with you a very interesting question based on linear equations. The question here is Sam is walking at a constant speed in front of a motion sensor. After 2 seconds, he is 1.5 meters away from the sensor. 2 seconds later, he is 4.5 meters from the sensor. How fast is Sam walking? Find the equation that describes Sam's motion in the form d equals to mt plus b. What is the d-intercept and what does it represent? You can always pause the video, answer the question, and then look into my suggestions. Now when you read through this question, you will understand that we have already given you the variables. The independent variable here is time and the dependent is distance, right? So any coordinate point which we look into will be in the form of time and distance, correct? Now if I read this again, Sam is walking at a constant speed in front of a motion sensor. After 2 seconds, he is 1.5 meter away. So 2 is time and 1.5 meter is distance, right? So I get one coordinate point which is 2 and the distance is 1.5. Is it okay? So let us call this point as A. So it's after 2 seconds he is 1.5 meters away from the sensor. 2 seconds later, that means now the time is 2 plus 2. That could be a mistake at times. 2 seconds later he is 4.5 meters. So the other point is B. 2 seconds later means we have to add 2 to the previous position, so it becomes 4. Now at 4 seconds from starting whatever, he is 4.5 meters from the sensor, 4.5 meters away. Do you see that? So that is how you could get 2 points. Now once you get 2 points, you can always write the equation which is of the form d equals to mt plus b, which is a linear equation, right? Now let's go through this one by one. A is how fast is Sam walking? Now when we have distance and time, we can always find speed as change in distance over change in time, right? So speed equals to, let me write like this, delta d, change in distance over change in time, correct? This is similar to thinking in lines that slope is equals to rise over run. Is it okay? Or you may say y2 minus y1, let me write here, y2 minus y1 over x2 minus x1, either way, correct? So all these are interpretations of what you've already learned. Since it's an application question, let's talk about what the question is related about, right? So it's really about speed, distance, and time. So we can now find the speed as change in distance. So final minus initials, it is 4.5 minus 1.5. Take away times, right? So 4 minus 2. That is how you could do it. Now 0.5 minus 0.5 is 0, 4 minus 1 is 3, and then we get 2 here, right? So that gives you 3 over 2. So let's write down how fast Sam is walking. So we can say speed is 3 over 2, or you can write 3 over 2. Units are important, meters and seconds. So meters per second, which is also, you could write in decimals, 1.5 meters per second, right? So I hope that makes sense. Now part B is find equation that describes Sam's motion in the form of d equals to mt plus b. We have already found m, which is the speed in this case. We need to find b. Now for finding b, you could use any point. So we have 2 points here. One is 2 and one is at 4, right? Let's use a. So if I use point A, I could write d as equals to m is 3 over 2, right? 3 over 2. And instead of t, I will write 2 plus b, right? B. So, and d distance is 1.5. So let me write this as equal to 1.5. So I'm using the point A, which is 2, 1.5 in the given equation, in this equation. So distance D is 1.5, correct? And time T is 2. Okay. Now we can solve for B. This is 1.5, so B equals to 0. So clearly, this cancels out. Okay, let's rewrite this. So once you cancel this out, we get 3 here. So we can write B equals to 1.5 minus 3, which is minus 1.5, correct? Since B is minus 1.5, I can write down the equation D as equal to M is 3 over 2, or you can write in terms of 1.5. Okay, let's write 1.5. 1.5t minus 1.5. You get an idea. So that is how you can write D. So that's solution for part B, correct? So we did part A here and B. C. What is the D-intercept and what does it represent? Now D-intercept is a point where the graph crosses the y-axis, correct? So where it crosses the D-intercept, D is along the y vertical axis. So D-intercept is a point where t is equal to 0. Do you understand? D-intercept is when t equals to 0. So in our case, B is the D-intercept. So for us, we can write minus 1.5 is the D-intercept, right? Since we have already calculated, so B corresponds to D-intercept. So let me make an arrow here showing what is D-intercept. D-intercept is actually the value of B, which is value when t equals to 0, right? So D equals to B, let me write here now, D equals to B if t equals to 0. Perfect. And in our case, B is equals to minus 1.5. Is that okay? So that becomes the D-intercept as a solution of part C, okay? So if you're looking at a graph for this particular function, let me just give you that here in this area. So it could be that we have now a D-intercept of 1.5, and if I write that is this, and if I write t equals to 0, that is when B equals to D. So it's a straight line which has a slope of 1.5 also, right? So it's kind of a line like this. Is it okay? Where this is your axis D in meters, this is time t in seconds, and that is your D-intercept at minus 1.5. You get an idea, right? And of course, you can put the other points on this line. 2 is 1.5, so let's say this is 2 with 1.5 and so on, correct? So I hope you understand how to interpret the given information and answer questions which are related to linear equations. Feel free to share my videos, post your comments, and if you like, that'd be great. Thank you and all the best.